Okay, so let's take a look at this question of the day in a little bit more detail. Okay, so here was the question of the day. Now I'm going to go over the chemistry involved behind it. So what we have here is an epoxide. We're treating this with sodium methoxide and methanol, and what is it that we get? So if we start here, we can really look at this. The sodium really isn't important. It's really the methoxide that's important, the minus charge. This can come in and attack the epoxide. It can ring open this, giving rise to the structure shown here, where we have the O-, the sodium counter ion, and we have the O methoxide. So this is obviously an SN2 reaction. And then once we've formed this alkoxide, we now need to protonate that minus charge with a hydrogen. So what is this hydrogen source? Can we use the solvent? So if we look at that, this mixture is sodium methoxide and methanol. So we've got a lot of methanol floating around. That's a protic solvent. Well, why not have the minus charge come in, pull off that hydrogen, and then give rise to the alcohol function? Well, the problem with this is, now that we form that negative charge, it can just go back and form the negative charge on the oxygen on the cyclic system, so we can go back and forth. So we're going to need another proton source. So typically in organic reactions, the chemist, when they're done, when they do it under basic conditions, will typically add some sort of acid, and kind of the generalized form of writing an acid is H3O+, shown here. So now that negative charge can come in here rather than grabbing the solvent, can grab this hydrogen, giving rise to the protonated form of the alcohol and water. But what we should now be thinking about is, well, we talked about this reaction here with the methoxide could come in and deprotonate. What's going to stop it from doing that? Well, when you add the acid, you add so much of it that not only are you going to protonate your oxygen, the negative charge on the oxygen of the final product that you want, but you're also going to protonate the negative charge of the alkoxide, the sodium methoxide. So that can grab the hydrogen, we can get water and methanol, and now we've a term that I use is quenched, means it gets rid of all of the negative charges. So if we look at the overall sequence, we have our epoxide, we've ring opened with an SN2 reaction, and we've gotten this methoxy alcohol. But this actually isn't the correct way. What I should have written it was this way, where we have this trans stereochemical relationship, where in this case I've drawn the OH up and the methoxy down. But you might be asking yourself, well, why couldn't we have drawn it in a lot of different conformations, such as here? If you look on this side, we have the methoxy down, the OH up. Well, why couldn't we have done the OH could have attacked up here, and the methoxy could have been down? So you can see that there's really 4 different ways that we could represent this. So why did I choose the one that I chose? Well, let's look at these a little bit more detail. If we take this structure on the left and we were to draw a dotted line through it, almost like a pole, and now we're going to rotate that, what's going to happen is we're going to rotate this such that we're going to take this red methoxy and we're going to replace it with the OH, and we're going to take this OH and rotate it so it's on the methoxy. And when you do that, now you can see that the OH is going to be up and the methoxy is going to be down, and that's essentially the exact same compound as the one we've shown here. And now you can see where this is going. We're going to do the same thing for this. If we rotate the methoxy where the OH is and the OH where the methoxy is, we get the same compound. So really what we're dealing with are these 2 compounds drawn here, where we have a trans stereochemical relationship. So how is it that we can get both of these? So now we actually have to go back and redefine the starting material. Rather than drawing just a straight line, we actually have 2 different epoxides. So we have really what this could be considered what we can call as a racemic mixture. We have both the epoxide up and the epoxide down in the reaction mixture. So what chemists will usually do is just draw a straight line denoting the fact that the stereochemistry is not set. But now that we know this, if we go back here, we can look, if we go to the left-hand side, the methoxy in this case would attack from above, since the epoxide is pointing down, which means it's pointing essentially through your computer screen to behind it. It's going to react, and that'll give your methoxy up and your OH down. And then on this case, on the right-hand side, the methoxy is going to attack from below, from behind the computer screen where the epoxide now is facing, pointing towards you. It's going to attack, give you the methoxy back and the OH up, since we know this is an SN2 reaction.